this lecture, we'll be discussing chapter 11, and this is all about thermodynamic relations. So the objective of this chapter is to determine or get the thermodynamic relations that allow internal energy, enthalpy, and entropy, and other thermodynamics for simple compressible systems to be evaluated from data. Okay, so what this means is from the data like pressure, temperature, specific volume, or those quantities that can be determined experimentally, we will be able to determine internal energy, enthalpy, and entropy. So these quantities or properties which are available in your STEM tables are actually calculated from those quantities that are obtained experimentally. So actually, you do this because ang internal energy is very or it's hard to get this experimentally, no? Lisod ni siya kuwaon kay because it involves many components, no? Internal energy as well as enthalpy. Ang enthalpy is U plus PV, so it involves internal energy as well as the entropy, no? So these properties cannot be measured experimentally, so that is why it is calculated. Okay, so we'll the first part is the equation of state. So for gases, so we need this equations of state. So for example, the ideal gas equation. So ang ideal gas equation is applicable only, no, when the condition is of the substance is naana sa gaseous nga state, no? So dili ni siya ma-apply sa kaning sa two-phase region, or kung i-apply nimo ni sa vapor nga region, dako kay error. So naay mga improvements sa ana, ang isa na isang van der Waals equation. So kaning van der Waals mao ni ang van der Waals equation. So this is an improvement sa imong ideal gas equation. So unsay difference nila is na kay duha ka constant A and B. Okay? So mo ni siya. Now, kung 0 ning A and B, mabalik ni siya sa ideal gas equation. So unsa ang pagkuha sa A and B? Kani siya. This one, it is based from the critical pressure and temperature of the substance. So nakuha ni siya. Okay? Dili kay ta magbugay diha, and i-improve na pod ang ideal gas equation ni siya ang Redlich-Kwong equation. Again, this is a two constant equation, Redlich-Kwong equation. So, again, ang A and B niya, kani, makuha base, dani. Okay. Ito na yung skip. And, we'll proceed this one. Diri sa actually, katong duha ka equation, Redlich-Kwong equation, van der Waals equation, we will use this actually later on. So, we'll proceed with the important mathematical relations. So, this is a review no, for the definition of an exact differential if the function ni mong z is a function of two variables. Okay? So, ang definition na ng exact differential is this one. dz is equal to partial of z with respect to x by letting y constant dx plus partial of z with respect to y dy. Okay? And then, if you let kani nga term, partial of z with respect to x to be m, and then kani n, ma-test nimo nga exact na siya when partial of m with respect to y is equal to partial of n with respect to x. So, nani siya sa advanced math. Test of exactness. So, unsaon nimo pag-determine whether ang isa ka differential equation is an exact differential. So, you get this one. So, unsa may pasabot ani niya? Actually, ang pasabot ani niya is you get the mixed derivative of the equation. Dapat equal sila. Ang m nimo is with respect to x man una, and then differentiate with respect to y, equal siya sa kani. Test of exactness. And another property is this one. If you multiply this one, is equal to 1, and then kani equal to negative 1. Okay? Okay, so practice how to write the exact differential of x if x is function of y and z. So, buhaton ni mana is dx is equal to, evaluate nimo ang partial derivative of x with respect to y, and then multiply by dy plus partial of x with respect to z dz. So, in the same way, kani, exact differential sa dy. Okay? Okay. So, this is the PV diagram and pressure temperature diagram. So, sa PV diagram, kaninga line is constant lines of constant temperature. Okay? And then, ang slope sa pressure with respect to V at critical point is 0. No? Kaya maana ang guna siya dire. Ang slope na dire is 1, 0. Okay? Now, applying mathematical relations, ito lang ni again siya, no? For van der Waals equation of state, determine an expression for exact differential dp. So, van der Waals dp. Ang van der Waals equation nimo is van der Waals. Okay, this is the van der Waals equation. So, ang equation ni mga pressure is a function of constant ang R, A, and B. So, function of T and V. So, ang bato ni mo na kay function of T and V man siya, get the exact differential. So partial of P with respect to T, una, let constant volume dt plus partial of B respect to P respect to B, constant T dV. And then, imo na yun itong differentiate ang kaning equation, van der Waals equation. So, makuha na dahil mo ni. dP is R minus over B minus B dt plus kani. No? So, that is how you get the exact differential. Okay, so let's proceed with the property relations. For today, we will make two property, or we will derive two new properties. Mga bago ni siya nga properties we call the Helmholtz function psi and Gibbs function g. So mga bago ni siya nga function, and then unsa may bago nga property, no? Bago ni siya nga property because it is a function of U, temperature, and entropy. So kaning tulo property man ni, so property pud ni siya. Just like this one. Just like the enthalpy, ang enthalpy is U plus PB. No? So ang Helmholtz function and Gibbs function for the present discussion, wala ni siya physical significance. Wala siya physical significances like the enthalpy, wala man siya physical significance. Ang value niya is U plus PV. So, pero property ni siya. Kay property, i-derive man siya from property. So, ato nang i-defining Helmholtz function and Gibbs function. And again, ang atong objective ani is maka-derive ta og equation for enthalpy, entropy, and internal energy, no? Nga makalculate nato siya. So, mo na itong objective ani, how to calculate internal energy, enthalpy, and entropy. So, actually, ito na siyang i-calculate because ninana na sa pagbuhat sa table, no? So kung makabalo ka na pag-calculate ana, and then you can construct the step table. Okay? So based on this equation, okay, we already know these two equations, du and dh. Ang bago lang sa tuwa is Helmholtz function. Okay, which is u minus ts, Gibbs function is h minus ts. And then if we differentiate this one, this becomes du minus the derivative of ts, which is minus tds minus sdt. Okay? And then kani atong i-plug in di ani. Okay? Di ani. So i-plug in. So ato na siyang i-derive. Okay, we will derive the differential of the Helmholtz function. Okay. E is u minus es, and the Gibbs function is h minus t. So differentiate this one, it becomes du minus t ds minus s dt. And from the previous equation, we know that du is just tds minus tdp, and then minus ds minus dt. So this cancel out. So the differential of the function is minus pdv minus dt. Okay? So that is the differential of the Waals function. And for the Gibbs function, the differential of Gibbs function, dh minus tds minus dt. And we've learned that dh is just tds plus ddt. Okay? Minus tds minus dt cancel. Differential of the Gibbs function is pdp minus s dt. Okay? So, una siya ang differential sa Gibbs and Helmholtz function. Okay. Now, we'll expand this further and we will develop what we call the Maxwell relations. Take note, ng objective nato aning pag-derive ani is to be able to determine U, H, and S, or to be able to calculate. And also calculate the change in internal, change in enthalpy, and change in entropy. Okay? Muna tong objective. Now, in order to determine or derive the Maxwell relations, we'll use the concept of exact differential. Now, ang imong internal energy is function of entropy and specific volume. Your enthalpy is function of entropy and pressure. Helmholtz function and the Gibbs function is a function of temperature and pressure. Okay? For this internal energy, the exact differential of the internal energy, if this is a function of entropy and volume, it's just u, a partial of u with respect to s. Take volume as constant, s plus partial of u with respect to v, constant entropy dv. So, mo na siya. And then, kung ato ning i-compare sa katong previous equation, du plus tds minus tds minus tdb. Ano sa'yo nakita ninyo? Sa'yo makonclude ninyo yan? No? So, same. Therefore, you can conclude that temperature is just equal to partial of u with respect to s, constant volume. And then, negative of pressure is just partial of u with respect to v. So, mo na siya. And then, for this one, the enthalpy is a function of S, entropy, and pressure. So, get the exact differential dH is the partial of H plus okay. And then again from the TDS equation, this is just TDS plus B dP. Again, so ma-conclude na to, ano? Temperature is just equal to partial of H with respect to S, constant pressure. Volume is just okay. So for the Helmholtz function, the function of volume and temperature, we get the exact differential partial of okay. And then compare na to na siya sa atong na-derive na equation kanina minus PdV minus SdP. Again, therefore, negative P is just negative P is just partial of psi with respect to the constant temperature, and negative S is equal to partial of psi with respect to the constant volume. Okay, last is the Gibbs function of temperature and pressure. So partial of okay. Compare that one to the derive na to. PdP minus SdP. Okay, kanikal span to ano. So, we have negative S is equal to partial of G with respect to T, and volume is partial of G with respect to T. So, ano siya? Okay. So, pila ni siya ka-relation? 1, 2, 3, 4, 5, 6, 7, 8. Natay 8 equations. Okay. We have 8 equations. And then, so sa'yo nakita ninyo aning equations. Based on these relations, we now have a way to calculate sample entropy using this differential, partial of psi with respect to T, or the Helmholtz function. Assuming wala pa tayo table. So nanatay way to get the entropy. Okay? So, mao na siya. And then, since kaning duha is negative S, so kanang mga same. So, pwede nato na sila i-equate. No? Ba silang i-equate? Ni partial of makakuha tawag another relation. Partial of G with respect to T. Okay? By the way, before nato na buhaton, okay, before we derive this one, or equate that one, we'll first derive the Maxwell relations. Maxwell relations. Okay? Now, based on the Maxwell relations, we can assess a exact differential. Diba? Partial of m with respect to y is partial of n with respect to x, where your m is partial of the variable with respect to x. Okay? So, atong buhaton, kani is gikan man isa sa u partial of s and v. Okay, kani. So, ato ni siyang second derivative. At this time, we will use kani, may muna na partial of t with respect to s man so v na with respect to v. Constant s is equal to partial okay, partial of n with respect to kani man atong buhaton partial of n with respect to y, kani atong buhaton. So kanina po datong a differentiate negative partial of t with respect to s. Okay? So muna to ang relation number 1. Base ani. No? Now, based on enthalpy. Based on enthalpy, kanina po datong i-differentiate. Partial of t respect to p constant s equal to partial of g with respect to s. Okay? And then, manani sila base dire kanina po kanina itong differentiate negative partial of is equal to negative partial of s respect to v. Ano lang na yung reason? Siya. Negative, cancel. Negative. Okay. And then lastly, negative partial of s equal to partial of v respect to t. Okay? So, mao na siya. So kaning upat karon mo ni gitawag og Maxwell relations. Ano say Maxwell relations? Now sa table 11.1 summarize na siya. And then katong kaganina ato na silang equate ning kani sa 4 kani. Sige man ni silang negative s negative s. May mo ning partial of psi respectively partial of g with respect to t. So that's another relation. Okay? Partial of okay. And then another relation is kani temperature. So partial of u is partial of h. Okay. Another relation. This one. Kani mo na kani pressure. So partial of psi partial of dili lang partial of psi partial of g kaning pressure partial of u. Okay. Temperature, pressure, volume. Partial of h partial of g. Okay? So, mo ni sila tanan ang imong mga relations. No, mga property relations. Okay, so we have an example here and this applies the Maxwell relations. So, asa gamit ang Maxwell relations? So, ato lang niya evaluate the partial derivative of partial of entropy with respect to volume, constant temperature, for water vapor at a state fixed by a temperature of 240 degrees Celsius and a specific volume of 0.4646 m³ per kilogram. Use Ridley-Kwong equation of state and appropriate Maxwell relation. Check the value obtained using steam table data. So, based on the problem, we can actually use Maxwell relations and compare it to the steam table data. Now, so if we don't have steam table data, we now have a way to determine the property of or the slope of entropy and volume. Okay, so how do we do this one? So we will use the Ridley-Kwong equation. So this is the Ridley-Kwong equation, and no, this is not the Ridley-Kwong equation. The Ridley-Kwong equation is this one. This one. Okay. This one. Kaning equation. Pressure as a function of temperature volume. Okay? Okay. So, based on that one, ang ipangita is partial of S with respect to V. function of constant t. Now, kung tanaw na nimo sa Maxwell relations, S over V. S over V. Okay. Ano? Aka na eh. Partial of S with respect to V constant T is equal to partial of T with respect to temperature at constant volume. So, meaning ani, kanide siya nga parameter, pwede na to isdan ani. Equivalent plus la ani. So, mas dali na siya, no? Partial of T with respect to T. So, ang buhaton nimo sa Redley kong equation, differentiate nimo siya with respect to temperature, but let the volume constant. No? Constant volume. And so, kani yung makuha. So, mo na din siya. Mo na din i-plug in ang mga values ani, and you will get that it is equal to 1.0043. Okay? So, mo na niya ang answer, 1.0043, based on the Maxwell relation. Now, ito ni siyang pangitawon sa table. Gayon dire nga fix ang temperature at 240. Actually, kung tanawon nimo nisa sa table, kaning temperature superheated ni siya, superheated vapor. So, imo ning ay superheated vapor man, imo ni silang i-plot. Kaya ang ipangita man nimo is partial of S with respect to V. So, na kay entropy, na kay specific volume, i-plot nimo ning duha, no? Kani mong makuha. And then, again man dito na 0.4646 ang volume, which corresponds to 5 bar. So, diri ka sa 5 bar makuha og slope. Kaya ang kaning slope para man na? And then, kaning slope, valued ani based on this one is 1.033. 1.033. So, pila na siya? 1.0043. So, kita nato nga nag-agree ra ang Redley pong equation. Okay? So, makita nato na pwede good gamiton ang Maxwell relation. And we now have a way to get the property using Maxwell relations. Okay, we'll proceed. This one, by the way, wala pa ta naabot sa to objective now, which is to get an equation for entropy, enthalpy, and internal energy. So, ito nang buhaton karon. So, again, mao ni ang ila ang mga property nga atong gamiton. Okay? First, nato nga kukuhaan og equation for the change in entropy, change in internal energy is kaning a substance that undergoes phase change. No? Ang substance ko nag-undergo phase change. So, dali ra kay na siya kung naka-steam table. Itawon mo sa table. So, karon, what if wala kay table? Ang buhaton ni mana is you will use this equation. dH is equal to TdS. Diba? Diba? Unsa gito? dH is equal to TdS minus VdP. But since sa kaning phase change, constant pa nimong pressure ana, so zero to siya. Kanila mabilin. Therefore, integrate nimo na siya, you will get this equation. Now for the change in entropy. And then for the change in specific internal energy, kani siya is imo ni siyang integrate gyapon. So ninani ang may tabo. So the change in specific enthalpy can be obtained using Clapeyron equation. So ang Clapeyron equation is this one. So asa na siya gikuha? Gikuha na siya. By the way, ang common sa entropy of internal energy is they need this value Hg minus Hf. So asa nimo ni kuhaon? Dili nimo kuhaon sa Clapeyron equation. So gikan dire partial of S with respect to V constant temperature is equal to partial of P with respect to T constant volume. And then in a phase change, ang temperature nimo is fixed. Therefore, the pressure is independent of specific volume only. So mahimo na ni siyang di na siya partial kay exact na siya dP over dt at saturation pressure. Okay, so based on this one, kani siya nga term is equal na ani. And then since the right side of this equation is fixed when the temperature is specified, pwede nato ni siya i-integrate, no? Kay constant sa phase change is constant imong temperature. So kani ito ning evaluate, mahimo na dayon ning Sg minus Sf dP over dt times kani Vg minus Bf. And then kani nga equation ato ning butang dere, puha na nato ni that the change in enthalpy is just dP over dt at saturation times temperature times Vg minus Bf. Okay, ang pressure, temperature, specific volume, mas dali makuha na sila experimentally. So therefore, pag nanakaani, plug in na nimo dire, kuha na nimo ni. And also this one. So muna siya for substance undergoing phase change. Now for substance at single phase region, single phase, so isa lang ka phase, no? Buhaton nimo na is by the way, so nanatay way of getting the change in entropy, change in internal energy and enthalpy using this equation, the Clapeyron equation. Okay, let's proceed. Considering single phase regions, so lahi po ang ilang pagkuha sa entropy, internal energy and enthalpy. For single phase regions, we will try to get an expression to get the change in internal energy, enthalpy, and entropy for single phase regions. So there are two choices which we can use. First is we can First, we can model entropy as function of temperature on a specific volume, and or model this one as function of temperature and pressure. Okay. So, kung kanino mong gamiton, you will arrive at another set of equation as compare kung kanino mong gamiton. First, if kanino itong gamiton, you can derive that the exact differential of entropy is partial of S respect to T dt plus partial of S respect to V san T dV. Okay? And then, from the Maxwell relation, kani siya, this is just equal to, okay, recall yung Maxwell relation, this is just equal to partial of T with respect to T at constant volume. Okay? So, muna siya. And then, we will also derive internal energy as function of temperature and volume. So, you have du partial of u partial of t dt plus partial of u partial of v dv. Now, in a term, this is just equal to the specific heat at constant volume kaning term plus partial of u partial of v dv. Okay? Ito na siyang karong substitute to the TDS equation. Okay? Ano? Ito ning substitute na rin, no? May mo ning dv dt plus partial of u partial of v t dv equal to okay, so we will substitute the value of ds, which is this one, yan So we have t partial of s dt plus t partial of p partial of p dv minus p dv. And then we will collect all dv and all dt. So, have partial of u kani so plus p minus t partial of p partial of dv equal to t partial of s partial of t minus cv. Okay? Muna siya. And then, since specific volume and temperature can be varied, no? Within that, there are two cases. First case is we let dv equal to 0 So therefore, kung 0 ni, ano na lang mabilin. So you have 0 is equal to T partial of S minus CV. Or partial of S respect to T is equal to CV over T. So that is the first case. Now, the second case, when dt is equal to 0, tanan 0, you have partial of U, partial of V, plus P, transpose na sa bigas, equal to T partial of P partial of P minus P. Okay? So, ano siya? And then, ato na siyang insert balik yan no? Kani siya naman na diri kani na insert balik diri so result tuning insert balik diri you have ds is equal to cv over t dt plus partial of p partial of t. Okay, so muna siya. Kaya atong objective man is that change in entropy. So kanito integrate nato ni from 1 to 2. You have S2 minus S1 is equal to integral from 1 to 2 CB dt over T. Okay. Now, ano siya ka term para ma-evaluate nimo ni dapat nakay expression ng CV as a function of temperature. Unsay behavior aning CV as function of temperature para ma-integrate mo as well as kani slope of pressure and temperature kuha na nimo sa data kinanglan nimo ni also. And then kani tuning i-substitute balik dini. Therefore, kung sa may tabo, you have du cb dt plus ni t partial of t partial of t b minus p dv. And then atoning integrate, you have u2 minus u1 plus minus p. Okay, so naana kay equation for change in enthalpy and change in entropy. Okay. So that is the first scenario, no? Kung kanimo gamiton. Now, in the event nga kanimo gamiton, motor na pud ni, lain na pud siya. Same pamaagir gyapon. So kani mahimo ning respect to P Mo na siya. No? And then, partial of S with respect to P is equal to, using the Maxwell relation, equal na siya sa negative partial of B with respect to temperature. So, muna equivalent niya. Okay? Very wrong din. Pressure na. Yes. And then, we'll model also enthalpy as a function of temperature and pressure. Na. So, meron. H is partial of H. Okay. So, muna siya. Take note kani, again, is the specific constant pressure plus and then we will substitute this one sa equation. Okay. Na to step by step, pero ang resulting equation na will be this one. Partial of H partial of P plus T. Same process lang po sila. Partial of D minus B dP is equal to T partial of S T minus C. Okay. So, muna ang resulting equation. Now, first scenario, let dP equal to 0. Therefore, you have partial of S Cp over, and then we let dt equal to 0. You have partial of H V minus T partial of V of T. Okay. Okay, so again, we'll substitute this value in this equation. Okay, so that we can derive the equation for enthalpy. Change in enthalpy. ds is equal to Cp over T minus partial of D. Okay, then we will integrate this one. So we have integral of Cp over T minus partial of D. Okay, so this is your change in entropy, and we will substitute this one this equation. So you have change in entropy is equal to enthalpy rather dp dt, and then integral plus v minus t partial of v. Okay, so muna siya. Okay, so naay duha ka set of equation. So asa ang gamiton ani? Now depende na sa given nimo. So, kung given nimo is temperature and specific volume, kato isa ang gamiton. Kani temperature and pressure, kani pwede mo makuha, but again makuha nimo ang relation sa enthalpy and internal energy using this equation, and then change in enthalpy limon draining minus plus other B2 B2 minus B1 oray bakaan. So naa natay equation for change in enthalpy, internal energy, and entropy. Okay, so here's an example of finding the change in entropy, internal energy, and enthalpy. So using the Redlich-Kwong equation of state, develop expressions for the changes in specific entropy, internal energy, and enthalpy of a gas between two states where the temperature is fixed. Okay, so this is the schematic constant temperature process from 1 to 2, and we will going to find the change in entropy. So gamiton nato is kani nga equation. Okay, so we'll use the equations for single phase. Okay, since this is a gas. So if we recall, the equations for finding the entropy is this one. Okay, and for now, we will use okay, we will use this kanitong gamiton, no? As compared ani nga naman kay ang Redlich-Kwong equation is p as a function man to siya, no? So mas dali evaluate ang wala man tani lisod man ni kwaon as compare ani kita na to later on. Okay, so using this equation, since constant temperature, so mahimo na ning 0 kanipod 0 dt kay constant temperature man, so kani ang mabilin kanina lang bro. Okay, so with that kani nabilin. Now anong yung kung mas dali ni kwaon because ang Redlich-Kwong equation is P is equal to ana no explicit siya tanaw na gud nato na B5 Redlich-Kwong equation. Kani Redlich-Kwong equation. Makuha nimo ang partial of P with respect to T, no? At constant volume, ani. Whereas kung ang partial of B with respect to T, lisod. Baon. So, muna akong pasabot. So, muna siya. Okay. Partial of P with respect to T. Constant volume. So, dali ra siya nakuha. Lagi na ni mo dire. Kuha ni mo nga expression. And for the internal energy, change in internal energy, again, kani gamiton na magyapon ni. Padong diyan ni. Actually, kani mo man ni. Kani. Internal energy is equal to ani. So, muna dire. Giderive niya. Ayan, naabot siya ani. So, actually, nanaw naman siya. And for other properties, like kani, coefficient of volume expansion, again, this is a Maxwell relation. Ikot sila. So, daghang kay gamit tong ato ang property relation na na-derive. You can actually get volume expansion, isothermal compressibility, isentropic compressibility. Yung kalahian na nilang duha is constant temperature ni constant entropy. Speed of sound, makuha speed of sound. Okay. Then change in specific heat na derive po niya gikan dire equivalent. Okay. Kani. Again, this is just the speed of sound. Joule-Thomson coefficient kani pud ang relation. Okay, we will proceed with constructing of tables of thermodynamic properties. So, based anto, dito gikan actually ang table. Kato nga mga relations. So, na duha ka pamagi ani sa pag-construct of table. First is kani yung gigamit niya ang specific heat at zero pressure. But also we can use the thermodynamic functions like Helmholtz function and Gibbs function. So kani. So ang gigamit sa same table is kaning relation. No, so kaning relation, the first step is selection of functional form in terms of upright pair of independent properties. So mo na siya kani nga format. And then overview ra ni siya no, important overview sa same table. And then kaning Q, kaning equivalent niya medyo taas po siya kay summation. And then kaning equivalent niya na. And then ay mga C constant, apoy A constant kaya po na siya. So, na example dire saon pagkuha ang value sa entropy using ani. Yan na siyang gi-derive dire. Anyway, medyo taas ni siya nga pamaagi no. Medyo taas na siya nga pamaagi, so di kabaluan na kanina lang po. First method. Yan. Developing table by using PBT and specific heat data. Okay? So gigamit niya diri is select datum, which is kani gigamit nga datum. Nag-assign po sa values ana. Then to determine the change in enthalpy, gigamit ang Clapeyron equation. Kani. And then next TDS, kani gigamit niya for S2 minus S1 for S3 minus S2. Again, this is the Maxwell relation. Kani. Okay. So, ikatong gipang derive nato actually is mo to siya ang gigamit para maka-construct sa table.